Hello everyone. Today we are going to look at our paper Unsupervised Cross-lingual Representation Learning at Scale. So this paper mainly deals with about the transformer-based mask model which was done over 100 languages using more than 2 TB data of filtered CommonCrawl data. The model which they are given here is an XLM-R model which significantly outperforms the multilingual BERT. XLM-R performs particularly well for low resource languages. In this paper, they show detailed empirical analysis of key factors, including trade-off between positive transfer and capacity dilution, performance of high and low resource languages at scale. In this paper, they showed for the first time the possibility of multilingual modeling without sacrificing per language performance, and it was also highly competitive on GLUE and XNLI benchmark with strong monolingual models. So let us go to the introduction. So what was the main goal of this paper? So the goal of this paper is to improve cross-lingual language. Understanding the cross-language means the main motto is to improve cross-lingual language understanding by carefully understanding the effect of training unsupervised cross-lingual representation at a very large scale. And as we know, the previously all of the studies which were done, it was done mainly on Wikipedia, which was highly limited for the low resource languages. Both mBERT and XLM have pushed the state of art for the cross-lingual understanding tasks by jointly pre-training large transformer models. These models allow for the effective cross-lingual transfer seen by the benchmarks, which were we used 3 benchmarks here. One was cross-lingual natural language interface, question answering, and named entity recognition. The main disadvantage which was of these were all of these studies were pre-trained on Wikipedia, as we discussed earlier, and it provided relatively limited scale, especially for low resource languages. In this paper, analysis of trade-off and limitation of multilingual presented, and this is what we call as the curse of multilinguality, which means more language leads to better cross-lingual performance on low resource languages up until a point, after which overall performance on monolingual and cross-lingual benchmark degrades, and it is one of the most important limitation which is even for our future XLM-R and all. Okay, so let's look at some of the previous work which was done in here. So previously Devin and Empel and Conius, they introduced mBERT and XLM trained on the multiple languages, but they didn't use any cross-lingual supervision. Means here in every language they were trained, but multiple languages were trained, but there was no cross verification of between two languages. But Lampel and Conius introduced TLM, translation language modeling, which was a way to leverage the parallel data, and it obtained a new state of the art on XNLI. What they did was for monolingual, like Josefovich showed that how large-scale LSTM model can obtain much stronger performance on language modeling benchmark when trained on billions of tokens. So, and GPT also highlight the importance of scaling the data. This helps us to show that mBERT and XLM are undertuned, and simple improvement in learning procedure of unsupervised MLM can lead to much better performance. Our work is mainly focused on unsupervised learning of cross-lingual representation and their transfer to discriminative task. So let's now look at the model. So as XLM-R model, it's mainly devised of the XLM model, and in XLM the BERT model which was there, it was trained on around 100 languages, but it was not optimized for multilingual models. To overcome that, XLM modifies BERT as XLM started using byte pair encoding BPE, which increased the shared vocab between different languages, while BERT uses words or character as input in the model. So this was one of the major difference, and another difference was in XLM, each sample of training consists of same text in two languages. Now model can use context from one of the languages and predict the token in other. In BERT we focused on the predicting the marks token mostly, but here we are trying to predict the marks token in another language using the context of the other languages. So disadvantage, what were the disadvantages with XLM? The main disadvantage with XLM was it requires parallel example, which can be difficult to obtain at a sufficient scale, while in XLM-R, which we will study now, it follows the self-supervised technique. And just for knowing what the byte pair was, the term byte pair encoding. The byte pair encoding refers to a compression algorithm. It represents very large vocabulary with a small set of words. So what we do here is we iteratively merge most frequent pair of consecutive bytes of character in a text corpus until the vocab size is reached. So let's go and look at the XLM-R model architecture at this point. So in this, what we do is we follow the same approach as XLM. We only introduce some few changes that improve the performance at scale. So here the XLM-R is a scaled version of XLM100. XLM-R is the masked language model trained on Roberta fashion. Roberta fashion means using masked language model objective. So the main working of this is it uses a transformer model and it is trained with multilingual objective using only monolingual data. So what does this mean? It simply means that the sample streams of text from each languages are used to train the model, and then it is used to predict the marks token in input using sentence piece with a unigram language model applying subword tokenization on the raw text. So the main aim is to mask one or more words in a sentence and give the model to predict the mask token given other word in the sentence. So the TLM objective extends the MLM to pair of parallel sentences. So what it does is it leverages the context of one language. Suppose you are given suppose you are given a sentence in French. So if it wants to predict a context in English, it can use the context from the French text and apply it to obtain the marks token in the English language. And one of the biggest update of the XLM-R was it provided an immense amount of the training data, which was around 2 to 2.5 terabyte of data, which uses the CommonCrawl data instead of Wikipedia. And what it did was, even for low resources, the one CommonCrawl data was enough for 12 of all other. Like it overall increases the size of the data set. So now this is one of the comparison between the CommonCrawl and Wikipedia. The orange colored one refers to the Wikipedia data and the blue color refers to the CommonCrawl data. So we can see that significantly the scale is much higher for the CommonCrawl as compared to Wikipedia. So with this large amount of data, it was highly possible for us to achieve much better result as compared to the previous models XLM and mBERT. Now these are some of the major results which were obtained. First of all, what our model showed was as the number of languages increases to a certain point, which was also the cursor multilinguality, that as the number of languages increases, the accuracy first starts to increase, but after a certain number of points it started decreasing the accuracy as per the number of languages. For high resource languages it was only normal. So okay, just for a notation, the blue colored bars represent the low resource languages, the orange color bar represents the high resource languages, and the gray color represents all of it together. So as you can see that the blue color bar started increasing at first as we increase the number of languages, but after it starts to reduce again. And we can easily point out here that okay, so as the number of languages first increases, the even for the low resource languages it starts to get more context, and that's why it was able to predict better. But as the number of languages keeps on increasing, it tries to give it a context in the multiple language for the same thing, and it confuses the model itself, so the accuracy starts to deplete. Similarly, and it shows the overall accuracy for low resource, high resource, and all. If we compare it with Wikipedia and CommonCrawl, if we use the Wikipedia, it was small for all of them, and when we use the CommonCrawl data, the overall accuracy itself increases, which shows that just changing the data set itself gives us a much better result. And here it's for the number of languages. If we keep the number of languages at fixed capacity, if at fixed capacity, if we try to increase the number of languages, the accuracy starts to fall down. But as if we keep it as increased capacity, the accuracy starts to be a bit higher than as compared to the fixed capacity. And this is one of the most important results which they found, and this is also why they chose the vocab size of the XLM-R model to be 250K in both XLM base and XLM Roberta base and XLM Roberta normal. So here if they keep on increasing the vocab size, they found that the accuracy was significantly increasing till 256k, but after that for fixed capacity it starts to deplete. So they used a 250k vocab size in the model itself, and this is one of the results as compared to BERT and Roberta. We can see from the result that it improved the accuracy to an extent here easily as compared to BERT. Can easily find out that its accuracy is slightly better than mBERT in compared to each individual language itself. Even if we are not taking care of for the multi, even for the single, for English to English only itself, it's giving a comparative better result as compared to mBERT. So our future work could be to improve the model against the curse of multilinguality. And for the conclusion, I would like to say that yes, XLM-R is the new state-of-the-art multilingual masked language model, and it is trained on 2.5 TB of newly created clean CommonCrawl data in around 100 languages. It provides strong improvement over previous multilingual models like mBERT and XLM on classification, sequence labeling, and question answering. It exposes the limitations of multilingual MLMs, in particular by uncovering high resource versus low resource trade-off. XLM-R is the first multilingual model and it outperforms the traditional monolingual baselines that rely on pre-trained model. So this XLM-R exposes the effectiveness of multilingual model over monolingual model, which shows how strong improvement it has gotten on the low resource languages. And with this, our presentation comes to a conclusion.